So now we're going to talk about the next part of the Java streams collect terminal operation lesson. Here we're going to talk about common Java predefined collectors and how to use them in conjunction with collect. And all the collectors we're going to talk about here were introduced in Java 8. There's other stuff that's come along later, but we aren't going to talk about those right now. And this is going to be something, as usual, you can get here at this link. And we're going to show them the Hamlet program again. So let's talk about some of the predefined collectors. So we already know that collect returns a collection, or it can return a collection. And a very, very, very common collection is a list. And so what you do if you do it like this, if you say collect toList, toList is kind of a shorthand for collectors.toList, but we've imported the collectors interface statically, so we can just say toList. And an array list, as you can imagine, is a list implemented as an array, and it contains or may contain duplicates. So in this particular case, if you were to run this program, you would see that we would have multiple Hamlets and multiple Laertes. And that's because, not Laertes, multiple Fortinbrasses. Fortinbras and Hamlet have confusingly the same name for two different characters, one of who was the king and one of who was the son of the king. And I won't get into the whole issue of analyzing Hamlet for you, but that's a very important theme of the play. So we've got duplicates, kind of like a clone army of stormtroopers. There could be duplicates. Collect is obviously much less error-prone than for each, since initialization takes place in the collector as opposed to you having to do it separately, and it's also thread safe. And I should also hasten to point out that you can use the toList variant in Java 16 and beyond. So toList is a shorthand version of a terminal operation that elides the need to, say, collect toList. There is a subtle difference, however. toList returns a so-called immutable list, whereas collect toList returns a mutable list. Mutable simply means you can make changes to the list. Immutable means you can't make changes to the list. And it's also worth noting real quickly that the concepts of immutability and mutability are orthogonal to the concepts of whether or not a stream contains stateful or stateless information. Immutability is really something that can be done. It's very commonly used for functional programs. But you can also program object-oriented programs using immutable objects. It's just less common because people who use object-oriented programming didn't obsess about it the way that people who do functional programming do. And there's a whole slew of other issues there that we're not going to go into right now, but just be aware those are independent concepts. We can also have a collector that returns a different kind of collection. So for example, if we say toSet here, which will return what's known as a HashSet, then the result that comes back will not have any duplicates. So remember, a set differs from a list in that the list may contain duplicates, a set will not contain duplicates. So if we say toSet, we get a HashSet. There's other kinds of sets you could have, tree sets and so on. We'll talk later about how you could do that. So in this case, we'd have independent elements where you don't have clones. There's no copies. These are just Star Trek characters that have their own unique identities and so on and so forth. And obviously, this is old school. I think this is old school Star Trek characters. This is the original generation, not the newer generation. For no other reason that I think I probably made these slides originally before a lot of the other movies came out. You can also collect the results into a map. So if you say collect, and then you use toMap, which of course is shorthand for collectors.toMap, then you're going to collect the results of the stream into a map. Now, what the heck does that mean? Well, what happens here is we say, I want the key in the map, because remember, maps have a key and a value pair. I want the key to be the identity function, which just means whatever the values in the stream are. And in this particular case, I want the values in the map to be the length of each character's name in Hamlet. And if it turns out that we have two characters with the same name, like Hamlet or Fortinbras, I want you to sum up the results and make that the value as opposed to just the original value. So it adds the two values together. This is what's commonly called a downstream collector, this third parameter. We'll talk more about that later. So this will make a hash map along with the length of entries, and it'll merge duplicate entry links together. So now we have a map of these things. And you may or may not know, but maps in Java are implemented in a very clever way. They start out being a hash table of linked lists. You probably studied that in your data structures class here, or wherever you took data structures. And what's cool about hash maps in Java is if it turns out that the linked list is getting long, like too many things are hashing to the same bucket in the hash table, then the map will automatically change itself to using balanced trees. So why is that significant? If you remember your data structures class, if you have them be linked lists, then the worst case performance will be O of n, because you have to put them in the list and search to make sure that there's no duplicates or whatever you're doing. You can have n of these things. But if you have a balanced tree, then it becomes log n again. So just an interesting little fact. And the reason that this was done by a colleague of mine, a friend of mine named Doug Lee, who did a lot of cool stuff in Java. The rationale was that there were denial of service attacks that were being done on websites that were using the Java hash map, where they were putting fake URIs or URLs that were all hashing to the same location. It would make the website get really slow. So they did this as a way to work around those denial of service attacks. So this mapping function produces the keys, this produces the length, and this merges things together. There's another group of methods that also can be used to create maps of various types. This type of map is just creating a hash map, as we said before. But you can also control the type of map you want to have created. And you can do that by using the groupingBy collector. So collectors.groupingBy. And in this case, once again, you have this concept of identity, which in this case would just be the names of the characters. You can then indicate, so identity is used to partition or classify the keys and put them in the map. So I think of it like a silverware drawer. And the tree map new is a constructor reference that you're passing in that tells groupingBy to use this map, not the hash map. So now you can control the type of map. And then the third parameter is the downstream collector, which defines a way to sum up things together. I think I misspoke earlier. I want to make sure I correct that to avoid confusion. This is not a downstream collector. This is just a merge function. This is the toMap method. For groupingBy, however, you can have this thing called a downstream collector, which will take the results from the classifier function, which was this guy. And so you take those, and then it'll take the results of that, and it'll call this other collector that will, in this particular case, sum the lengths up. Now, that's a very simple use. We'll talk about much more interesting use cases for downstream collectors later, because you can do custom downstream collectors that do all kinds of cool things, and we will do those at some later point. Just for fun, you can also have other ways of creating a stream. So up here, we were using a list of the characters, but you could also give it a string, a single string of all the names of the characters in Hamlet, and then use the pattern compile method using the comma as the splitter, and then you could split this string into a stream. Just showing it yet another way of being able to do the creation of a stream using regular expressions. Okay, so that's the end of the discussion of collect when it's used with different kinds of collectors like toList, toSet, toMap, groupingBy, and so on and so forth.